So hi everyone, so this is Sarab and I am gonna be explaining you about naive based classifier. So this is the video for EduVenture. So let's get started with the video. So what is naive based classification? So naive based classifiers are a collection of classification algorithms based on Bayes theorem. So basically they are actually based on Bayes theorem, the concept behind the Bayes theorem. So every pair of features being classified is independent of each other. So I will be showing you the features and how they are independent of each other. So it's not a single algorithm but a family of algorithms where all of them share a common principle. So here is a Gaussian graph for naive Bayes classification. So it's a trajectory for normal distribution. So there are three types of naive Bayes classifiers. So one is Bernoulli naive Bayes, so it predicts Boolean values, and multinomial naive Bayes. So if you want to determine whether a document belongs to the legal category or a human resource category. So I will show you in the dataset that how it differs. So then the last one is Gaussian naive Bayes. So if the predictors aren't discrete but have a continuous value, we assume that they are a sample from a Gaussian distribution. So let's talk about Bayes theorem. So Bayes theorem finds the probability of an event occurring given the probability of another event that has already occurred. So it's like I am assuming the value of PA/B where B has already occurred and A is we are calculating about the A. Okay, so again we are trying to find probability of event A given the event B is true. So like we have calculated it, right? So and other PA and PB are probability events before evidence is seen. So here is the picture. So it will help you gain more information. So PA/B, so probability of A occurring given evidence B has already occurred, and then probability of B occurring evidence A has already occurred. So this equals to this, and it's multiplication with this PA and division by PB. So it's like that. So here's naive assumption. So naive assumption to the Bayes theorem, which is independence among the features. So now we split evidence into independent parts. So if two events A and B are independent, then PA comma B equals to PAB. Okay, so according to Bayes theorem, which it says that Pyx1 comma xn till xn equals to this value. So on seeing that as a denominator remains constant, on removing we will get this value for our naive assumption. So here Py is a class probability and Pxi/y is conditional probability. Okay, so here we are getting our example data set. So it's about the flu, and we will gonna be also making a prediction on our Jupyter notebook as well. So I just calculated all the values. So these values are basically like how many times the event has occurred. Like the Y is like for yes, so it's 1, 2 and 3. So for Y equals to yes, there are three events. So basically all this data has been calculated like this only, and then there are total of 5 yes and 3 no's. Okay, so using this we can also calculate the values. So I will be showing you that how. So it's like values for chills, runny nose, headache, fever are, we are assuming the value to be y and no y. So chills yes, running nose no, headache no, and fever y. So we will be like py/nb flew, right? So it will be like for yes nb flew. So we will be calculating only the values which are just yes for nb flew, like yes for chilies, yes for running nose, so like that. So 3 by 5 into 1 by 5 into 1 by 5 into 4 by 5. At last we will also be multiplying the values which are like these values, so for p yes slash p no, so these are that values. Okay, so on calculating these values, so these values, it will result into this, and then on addition of these both we will be getting this, and then we will be dividing this value with this, and again this with this. So on clear division we will get 0.57, that is 57%, and 43.43, that is 43%. So our prediction will be yes, the person will be having a flu. So let's test it data set using sklearn. So we are having this demonstration video for our naive based classifier. So first of all, I'm using Jupyter Notebook because Jupyter Notebook is better for error handling and it's easy to use. So let's get to the code. So we are importing pandas first as pd, then we are importing pd.read csv. So using pandas we are importing csv file, the data set. So let's see the data set, and then we are gonna slice and pre-process the data because the data is categorical, like y, so these are categorical values. So we need to change these values to zeros and ones so that we can easily use it. So then we have actually imported the label encoder, which will help us in pre-processing the data. And then we have actually sliced the data like x1, x2, x3, x4. These are the 4 attributes which we will separate, and for like chills, runny nose, headache, fever, these will be separated, and the flu will be separated else in y form. So let's again do it, and then using label encoder. So we have actually assigned label encoders as LE to better use it. So there is a like library .fit transform which will change these values to zeros and ones. So let's again do it, and then we are gonna zip these x1, x2, x3, x4 into a table sort of, so into a data frame which is pandas data frame, and then assign to it as x. So let's print the x. So here is the data set which we have pre-processed, and then we are gonna fit the model. So we are using sklearn to demonstrate. So sklearn.naivebase import categorical nb, and then again we have assigned categorical nb to model, and then we have actually trained the data. So let me again write it. So we have trained the data using this thing. Wait. So we have trained the data, and so let's predict it. So for the prediction purpose we are using 1 0 1 1. So basically it's like 1 for yes, 0 for no, but it in this case 1 is for no, 2 is for strong, and 0 is for mild. So it's like 0 1 2. So like again 0 1 2. So it's like that. So here, see here, 0 1 2 0 1 2 2 0. So it's like that. So let's see if it predicts yes or no. So it's saying that it's yes. If we change the values to like make it 0, so it don't have any chills. So let's see if there are chances of flu or not. So yeah, so there are no chances of flu if it doesn't have chills, if it don't have runny nose, don't have headache, but yes for a fever. So then it doesn't, he or she don't have chances of flu. So it is the demonstration of naive Bayes classifier. So let's go back to the PPT. So we just saw the demonstration of this particular data set with sklearn.naive Bayes, and we got pretty accurate values. And let's move to the application part of view. And talking about applications, so this algorithm is really fast and efficient, so we can use it to make real-time predictions real easily. And also it is used in email services, like Gmail uses algorithm to figure out whether an email is spam or not. So this algorithm is excellent for spam filtering. Also, with collaborative filtering and the naive Bayes algorithm together, we also can make recommendation system out of it. So it's also really grateful for this particular algorithm. So thank you for watching the video. Hope you like it and got some information for it. So this was a sample video for EduVenture. So hope they also like. Thank you.